Okay, we move on to question 13, which reads as follows. The mug shop keeps all kinds of different interesting mugs. The shopkeeper starts working at 8 and stops at 1 o'clock in the afternoon. A certain collection contains 6 mugs put next to each other on a shelf. All right, so just let's see what this means. You've got 6 mugs. We'll just call them A, B, C, D, E. A, B, C, D, E, F. Okay, so they're all sitting on a shelf. It takes 55 minutes to arrange all the 6 mugs of this collection in all possible different arrangements. All right, so I think you should know by now that the number of arrangements of 6 objects is 6 factorial. And that is 720. So let's read this thing again. It takes 55 minutes to arrange all the 6 mugs of this collection in 720 ways. All right, so it takes 55 minutes. So it starts at 8 o'clock, and this is what happens. If he starts arranging the mugs from this collection exactly on the hour, every hour, and 1 mug from this collection gets sold in the last 5 minutes of each hour, how many different arrangements did the shopkeeper make in 1 day? So we have to see. Let's firstly understand this problem. So at 8 o'clock, from 8 to 8:55, he makes 720 arrangements. And then from 8:55 to 9 o'clock, in this last 5 minutes, it says that he sold one. He sold one of those 6, which meant now that he had only five mugs. And so from 9 to 9:55, so yeah, he had 5 mugs, 720 arrangements. So now he has to arrange 5 objects, and that is 5 factorial, which is actually 120. You see, 6 factorial is 6 times 5 factorial. So to get to 5 factorial, you have to divide 720 by 6, and that is what you get. So that's the number of arrangements there. Between 9:55 and 10 o'clock, he sold one, and from 10 to 10:55, he continues to starts arranging the remaining ones. All right, so from the 5, it came down to 4. So you have to divide this by 5 to get 4 factorial. Okay, 4 factorial is 24. I think you already know that, but you could have divided this by 5. And like that now, from 11 to 11:55, 4 factorial, it becomes 3 factorial. From 12 to 12:55, it's 2 factorial, which is 2. 2 factorial is 2 times 1. So he's only got 2 mugs at this stage, and the last one, yeah. So you can make one more arrangement. Right. So 8 o'clock, 6 factorial. 9 o'clock, 5 factorial. 10 o'clock, 4 factorial. 11 o'clock, 3 factorial. 12 o'clock, 2 factorial. So you get this number. And then the last, he makes those two arrangements, and then he sells the last one in the last 5 minutes. So how many arrangements are there altogether? We simply have to add all these numbers, which I have underlined. That's the question. So here you got 840, 864, 872. Total number of arrangements. The question is, how many arrangements does he make altogether? Okay, simply, you just have to add all those numbers which have been underlined. Also, so there you can see the answer is 872. All right. Uh, let's go down to question 14. Question 14 says the following. How many nines are there in 99,999 squared? Now you can multiply this number by itself. It'll take a long time. There's a good chance to make an error because there are so many calculations to be made. But we can simplify this problem considerably by noticing that this number here is only one short of 10 to the power of 5. 99,999 is one short of 100,000. 100,000 has got 5 zeros. So it's one short of that. So we can square this. And our mathematics tells us that the square of a minus b is a squared. So it's 10 to the 5 all squared minus 2 times 10 to the 5 plus 1 squared. Okay, and that is 10 to the power of 10. Minus 2 times 10 to the power of 5 plus 1. Okay, now 10 to the power of 10, I'm going to write this down. It's got 10 zeros in it. I'll put 1. Let's put them in threes. 3, 6, 9. Let's put 4. Okay, so that is 10 to the 10. You're going to subtract from this 2 times 10 to the power of 5. So this has got 5 zeros. So 2 times that is 200,000. Right? 10 to the 5, 10 to the 4 is 10,000. So 10 to the 5 is 100,000. So you're going to subtract 200,000 from this. Point is, it's got 5 zeros. 200,000 has got 5 zeros. Yeah. So you got 4, 1 more, and the 2 is there. So I'm going to subtract these 2 and I'm going to add 1 at the end. So when you subtract these 2, okay, we can see very quickly 0 minus 0, 0 minus 0. Now here you got 10 minus 2 is 8. And then you borrow 1. And after this, from this point onwards, you got a 9 under this 0, and you got 3 nines under these 3 zeros. Okay, and to this you're going to add 1. So this whole thing here added 1. Is that? And the question was, how many nines are there? And you can see the answer is 4. Because you can see 4 nines. So this is a long way of calculating this, but it's certainly much better than squaring 99,999 and counting the number of nines. So there's a nice short way of working out what that thing there squared is. Useful. All right. So let's get on to the next problem. Let's just check this one. Yeah, it's the same thing. So we got 4 nines. All right. Let's go to question 15. So what does question 15 say? A train moving at constant speed takes 4 seconds to cross the equator. Oh, the equator is just a single line. All right, so it takes 4 seconds to cross the equator. So let's just put the train here. Let's draw a little train. So the equator is a single line here. To cross this equator, the same train will be on the other side. Right. Now it takes 4 seconds to do that. So actually what happens in a problem like this, it's nice to look at the front of the train. There's the front, right? And you want to know what distance that has, the front, that's fixed point on the train, what distance has it moved to cross the equator? It's moved this distance. And the front is here. Okay, so we don't know that this is, the question is what is the length of the train in meters? All right, so we don't know. That is your x. X is the unknown, and we need to calculate that. Okay, so it covers this distance of x in 4 seconds. All right. So that means its speed, the speed of the train, is distance over time. We'll say x meters, and because everything is in meters. So the speed of the train is it's x meters in 4 seconds. So distance over time is the speed. And that is meters per second. X meters in 4 seconds. All right, so we got the speed of the train. Now it says here it completely passes a platform which is 75 meters long. Platform is, in a station, you have these platforms. So there's a platform here. 75 meters, and it completely goes across this. So there's your train, there's the front of your train. When it finishes, it goes right across and completely. So this is where the train is after crossing the platform. So you can see what distance the front has traveled. We said the length of the train is x. So this point here, the front of the train, has moved through 75, which is the distance, length of the platform, plus the length of the train, 75 plus x. So it covers 75 plus x meters in 9 seconds. Right? So this tells you the speed is 75 plus x over 9, and it's traveling at constant speed. So this is the same speed as the one that we that we had before. So this information is coming from the second part of the problem. This is in 9 seconds. So now we have an equation in x, you see. So if you cross multiply, you have 300, 4 times 75 plus 4x equals 9x. You bring all the x's to one side, you will see that you got x is equal to 60 meters. Okay, 9x minus 4x is 5x. 5x is 300. 5 times what is 300? 60. Okay, so that's the answer to that problem. Let's just check to see whether we made any errors. Right, okay, this is 60 meters. Let's get on to the next problem, which is question 16. Question 16 says, let x and y be real numbers in the equations. You've got two equations here, very odd equations. X cubed plus 3xy squared, 28, and so on. You've got two equations and two unknowns, but they're very unfamiliar equations. You've never seen any equations involving cubes and squares and products and so on, like that. We've seen linear equations and a quadratic equation, but never two cubic equations. And the question is not asking for what x and y are. They're asking for what is x to the sixth plus y to the sixth. All right, so let me see if I left a page for this. I have been leaving spaces. Yeah, okay. I've got a space for this. Let's repeat these equations. I had x cubed plus 3xy squared is 28, and y cubed plus 3yx squared is 26. And the question is, what is x to the power of 6 plus y to the power of 6? So that's the question. Now, I recognize these things here. You see, it's it's a cube of a sum. I've got all these objects here. Let me write down the formula. X plus y all cubed. It's very useful to remember this formula. And it seems that you're expected to know it since they asked us. So this is x cubed plus 3xy squared plus 3xy squared. No, when you're cubing it, it's 3x squared y. The x cubed, the x is reduced in power and the y is increased. So another 3xy squared and then y cubed. While you also have x minus y all cubed, and that is x cubed. And this time you have minus 3x squared y plus 3xy squared minus y cubed. When I was in school, I was taught this like this. You see, you square x, you get a cube this. Now you square this, multiply by the other one, and multiply by 3. So I get x squared times minus y gives you minus x squared y, and you multiply that by 3. You do the same thing right throughout. Okay, so now when I add these, I'm going to get that. You see? So x plus y all cubed is equal to this first term plus the second term, you see they are the same thing there. So when you add, you're going to get x plus y cubed, which is 28 plus 26, which is 54. And when you subtract these, you get x cubed minus y cubed. There it is. 3xy squared minus 3yx squared. 3xy squared minus 3yx squared. Right? That's it. And that is 28 minus 26 is 2. And so now we might be able to do something here because you got two cubes, and 54 over 22 I recognize to be 27, which is 3 cubed. So I'm sure that'll help. So if you put x plus y over x minus y all cubed, you will get this over this, which is 27, 54 over 2. So the cube of this expression here is 27. So this must be 3. Okay, now that simplifies considerably, because now you have x plus y equals 3x minus 3y to cross multiply. So where do you get from there? Well, that means that if we bring all the x's to one side, I get 3x minus x. If you look at it on the right-hand side, which is 2x. Three x minus x is y plus 3y, which is 4y, which gives you x equals 2y. All right, so now we found x in terms of y. Now that's powerful. It means I have only one equation. I can, wherever I see x, I'll put y. So let's do that in the first case. You got, wherever you see x, you put 2y. So you got 2y cubed minus 3 times 2y, y squared. I'm sorry, plus. X is 2y. And this is equal to 28. So this gives you 8y cubed plus 6y cubed. So this works out to 14y cubed equals 28. And that gives you y cubed equals 2. Works out nicely, 14y cubed. So no, difficult looking fractions. Okay, we can do the same thing for the second equation. I can substitute x equals 2y in the second equation. And I have the second equation has got a y cubed as a starting point. I'm now going to replace the x's. So I've got y cubed. And here I've got 3y. And x is 2y. So I'm going to replace x squared by 4y squared. Right? And that is 26. Okay, so you got y cubed, and this is 4y. 4 times 3 is 12. So I've got 12y cubed plus y cubed. So that gives you 13y cubed. It's 26. Again, you get a nice answer, y cubed equals 2. Ah, the same thing. Oh, I shouldn't have done that. I'm not finding y, I'm finding x. Okay, let me delete all this. I think I'll need a little bit more space. Remember, y cubed is equal to 2. Huh? So now let me calculate x. I know that y cubed is 2. So the last case, I actually landed up with exactly the same answer as before. The reason was I needed to find, I rubbed that out as well. Yeah, so we had 2x is equal to 4y, x is 4y. So x is to y. So we make y equal to x over 2. X is to y. So I'm going to replace y's now. Okay, so yeah, the first equation, it's x cubed, 3x. Your y is x over 2. So y squared is x squared over 4. And that's the only place where y occurs. So it's a good choice because only one substitution. If you made this, then you've got two substitutions which make life a little bit more difficult. Okay, so a common denominator of 4. Let's multiply right throughout by 4. 4x cubed plus 3x cubed. Multiplying right throughout by 4 is 112. So that gives you 7x cubed is equal to 112. So x cubed is 16. That works out very nicely as well. So I got x cubed is 16. And remember, we said y cubed is 2. And the question was this. What is x to the 6th plus y to the 6th? If we know x cubed and y cubed, then we should be able to work out the 6 powers just simply by squaring them. This is x cubed all squared. And this is y cubed all squared. We had that is 16 squared, which is 256. And y cubed squared is 2 squared, which is 4. So the answer to our question, according to my calculations, is 260. Okay, so just remember the answer is 260. Let me check to see whether this is the answer that is predicted. Ah, there it is. I think if you look at the thing, it's almost the same as what I did. All right. Let's now get on to the next question, which is we go to question 17. Okay, Jill and Jack's houses are at opposite ends of a park. So okay, there's Jack's house and Jill's house. And Jack bikes to Jill's house along the paths laid out in the park. So you can go directly like that, or you can go like that, or you can go straight down like this. So many ways in which you can get there. And how many different ways? So the question is, in how many different ways can Jack get to Jill's house? If you can only move north, east, or northeast. So in other words, you can move north, it's that direction, or east, or northeast, northeast. So in other words, along the sides of these triangles. Now, something, these questions appear very often, and I think I've already discussed them, but in case you haven't seen it before, so let's have a look at this problem. You see, here's an important fact. Suppose you got two locations, and you got a third location, and suppose you can get here in, say, A ways, and in various ways, you can get to this point here in A possible ways. And here, suppose you can get to this in B possible ways. There are various paths. I'm just taking these three dots here to be three dots somewhere here. All right. Now, and suppose these two are the only ones that link. Right? So, in how many ways can you get to this point here? Well, it's quite clear that these A ways, each one of them contributes one way, and these B ways, each contributes another way. So altogether, you have A plus B ways. I'll repeat that. Each of these A ways contributes one path, only one path along this, and there are A paths altogether. So there are A ways to get from this point to that point. And likewise, you have this. So when you got a setup like this, you can always add these two. Okay. And that's going to help a great deal because if you take this point here, oh, okay, let's take this point. There's only one way you can get to this point. So I'm going to put the number of ways in which you can get to a given point. I'm going to put that as a tag at that point. So this means that to get to this point, there's only one way. Likewise, to get to this point, there's only one way. You can only travel horizontally, right? But this is not the same, yeah, because you can go this way or this way. So there are two ways in which you can get to that point. See? No, what am I saying? Only one way. From here to here, it's only one way. All right. And likewise, no, I'm not wrong. Sorry. You can go this way or that way. There are two ways in which you can get to this point. All right. So let's see whether we can build up. For instance, here now, you got 2 plus 1 plus 1. There are three possible pathways. So that gives you 4. And then to get to this, you got that and that are the only ones that get to this. So you can make that 6. But here, I need to know what's happening here. So let's have a look at this. You got 1, 1. So this is 2. And, and so to get to this, the, the, there's no there's no road here. So the only way you can get to this is from here. So this is still 6 here. Okay, right. And now to get to this, it has to be 6 plus. Right, now you got 6 and 6, it gives you 12 here. So to get to this, there are two ways. The only these two parts. And in this case here, you got 12 plus 6 plus 2, which is 18. Right? So therefore, 30 ways. I don't know this is correct, but 4 ways, 4 plus 2 is 6. Here, there's only one way. All right, so my answer is 30. And let's hope that it is 30. Oh, it's 38. All right. So I missed a few. Let's just see what happened here. So, okay, I did have two. Let me just highlight these things. What's going on? Okay, so okay, all these were one. I didn't have a problem with that. Two plus one is four. I didn't have a problem with that. Six and six is 12. And then, oh, here I needed to work out six plus one. Right, from here to here. Six from here to here. So I think I made a mistake with this. So there's an eight here. So you got 12, 6, and 8. And in the end, you'll end up with 38. Okay. So you got the correct answer. You can just check that. I did not, I made some miscalculation. Let's now go to question 18. Question 18 says f of 1 is equal to 1. F of n is equal to n plus f of n minus 1 for all natural numbers. And you're asked to determine what is f of 30. Okay, so let's have a look at this. This is what you call a functional equation. Okay, I just want to get rid of this thing here. Now, f is a function which assigns to all natural numbers some number. Like for instance now, let's have a look at what this function is doing. If you take, you got n minus 1 here. So you could start with n equals 1 here, and f of, see, f of 30, you 1, 2, 3, 4, all the way up to 30. Now what is f of 30? F of 30 is, you put n equals 30, n is 30 here, and here you have f of 29. So therefore f of 30 is 30 plus f of 29. Right, but we don't know what f of 29 is. So 29, right, we put n equals 29 here. So you get f of 29 is equal to 29, n equals 29, plus f of 28. So f of 29 is 29 plus f of 28. Okay, so we still don't know what this is. But now you can replace this f of 29 by 29 plus f of 28. So this is equal to 30 plus 29 plus f of 28. If you keep going on like this, you will see that you're going to go to f of 30 will be 30 plus 29. This is 28 plus f of 27. So I'll put 28 plus f of 27. F of 27 is 27 plus f of 26. So you keep coming down like that until you come to f of 2, which will be 2 plus f of 1. That's f of 2, right? And f of 1 we already know is 1. So this part is 3. Or otherwise, you can put f of 1 is just 1. Don't have to add this thing up. So you eventually come down to f of 1, which we know. So f of 30 is just nothing else but 30 plus 29 plus 28 all the way to 1, because f of 1 is 1. And I think you should know that formula by now. This is the sum of all the numbers from 1 plus 2 all the way up to 30. And n into n plus 1 over 2. Okay, by now you should know, if you've been going systematically, that the formula for the sum of n consecutive numbers is n into n plus 1 over 2. So it's 15 times this 465. All right, let's check to see whether this is the answer. Oh, I've done something else. I still have 465. Let's see what I've done here. You've got f of 1 equals 1. F of 1 equals 1. F of 2, oh, so you made this f of n minus f of n minus 1 is n. I kept it as f of n equals n plus. But if you bring this to this side, then you get this, the difference between the values at two consecutive numbers. That should help a great deal. Like you got f of 2 minus f of 1 is n. So it's 2. F of 3 minus f of 2. These are consecutive numbers. And then n minus 1. And that'll be 3. So it writes all these things down. Then we say add both sides. So what does this mean? So when I add all these numbers here, f of 1 cancels off with f of 1. F of 2, f of 3, f of 4, and f of 29 will evidently cancel off. So on the left-hand side, there's only one survivor. That is f of 30. And on the right-hand side, you got 1 plus 2 plus 3, all the way up to 30. This is what we saw earlier on. Okay? And that answer is 465. All right, so that takes care of that problem. It's nice to see that there was another way of doing this. Um, let's get on to the next problem, which is question 19. The circumcircle. Circumcircle means the circumscribed circle of square ABCD. And you see here, there's your ABCD. And you got a circle which circumscribes. In other words, it contains the four vertices of that square. This is a square. So you got a square, you got a circle which goes around this, and that has got radius 10. Its radius is 10. Now, where is the center of the circle? The center of the circle will be where the two diagonals intersect. It's nice to know these facts. The squares are very heavily tested. So a square has got various properties, but amongst them, you've got that the diagonals are equal, and being a parallelogram, they bisect each other. So it means that all these lines which come out from here, they're all equal. So that has to be radius now, you see, because this is the distance from where so the center of the circle is the center of the square, where the two diagonals meet. Okay. it says that this thing has got radius 10, so this is 10. All these are 10. Like circumcircle is drawn on AB outside the square. So you got a circumcircle, a circumscribed circle, right? And determine the area of the shaded region. All right, now, these problems, you have some way strange shapes, but these shapes can be calculated by using known shapes and known areas. Like the way to tackle this is, I will put, let, let the shaded area be A, let that be B, and let that C, right? So you got C is the area of a triangle, and the area of the triangle, oh yeah, the other property of a square is that the diagonals bisect each other, as you can see, but at right angles, right? We will use this fact again later on. The diagonal of the square bisect each other at right angles. So therefore, the area of the square is half base times height. The base, if you take it as 10, so you got the area C is 50. Now B is, that's a funny looking shape, but you can say it is the same as B plus C minus C. If you add this part here, then I've got a quarter circle, you see. So let me add this triangle here. Then I got a quarter circle. And the area of a quarter circle, it's quarter of the area of the whole circle. And we saw that the area is, well, no, we didn't see, but the area of the whole circle, the radius is 10. So it's pi r squared. So 10 squared is 100. Put the pi afterwards. Pi times 10 squared is 100 pi. And that is your B plus C. And then you're going to subtract from that the area of the triangle. I don't know whether I need all this. It's, anyway, it's good exercise. If the area of the triangle we saw is 50, so it's 25 pi minus 50. Okay, and then once you got B, then A, we can see A plus B is the area of the semicircle. It said that this is a semicircle. And the area of the semicircle is, suppose AB is D, it's the diameter. It's the diameter of the circle. So A plus B is really it's half of, it's a semicircle, you see. So it's half of the full circle. And the full circle has got, the area is pi r squared with the full circle. And r is d over 2 because I'm calling this d the diameter. All right, so, but you know the d squared, according to Pythagoras, d squared is 100 plus 100. Which is 200. So A plus B is, you got a half, you got all this, no, 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 only the radius is squared, sorry. It's half pi r squared. So the d squared over 4, and then another 2 there, so the d squared over 8. 1 over 8 d squared. But d, you can calculate that. That is 1 over 8 into 10 squared plus 10 squared, because that's a This theorem of Pythagoras is so powerful. So you got 100 plus 100, which is 200. 1/8 of that is 25. 25 pi, actually. 25 pi. So I go. So, so I know what B is, and I need to calculate A. So A is equal to 25 pi minus B, and that is 25 pi minus, I calculated B to be 25 pi minus 50, right? And when you subtract these, interestingly, the 25 pi will cancel off. So the area that you're looking for is actually 50 units. I'm sure there's an easy way of doing it, but it's interesting. It's, yeah. So that's question 19.